IID draws. Because big Y sub 1 through big Y sub n are randomly drawn from the same population, the marginal distribution of big Y sub I is the same for each I equals 1 through n. This marginal distribution is the distribution of big Y in the population being sampled. When big Y sub I has the same marginal distribution for I equals 1 through n, then big Y sub 1 through big Y sub n are said to be identically distributed. Under simple random sampling, knowing the value of big Y sub 1 provides no information about big Y sub 2, so the conditional distribution of big Y sub 2 given big Y sub 1 is the same as the marginal distribution of big Y sub 2. In other words, under simple random sampling, big Y sub 1 is distributed independently of big Y sub 2 through big Y sub n, when big Y sub 1 through big Y sub n are drawn from the sample distribution and are independently distributed. They are said to be independently and identically distributed, IID. Simple random sampling and IID draws are summarized in Key Concept 2.5. Sampling distribution of the sample average. The sample average or sample mean, big Y bar, of the n observations big Y sub 1 through big Y sub n is big Y bar equals 1 over n multiplied by open big Y sub 1 plus big Y sub 2 through big Y sub n close equals 1 over n multiplied by the sum from I equals 1 to n of big Y sub I, equation 2.44. An essential concept is that the act of drawing a random sample has the effect of making the sample average big Y bar a random variable. Because the sample was drawn at random, the value of each big Y sub I is random. Because big Y sub 1 through big Y sub n are random, their average is random. Had a different sample been drawn, then the observations and their sample average would have been different. The value of big Y sub, the value of big Y bar differs from one randomly drawn sample to the next. For example, suppose our student commuter selected 5 days at random to record her commute times and then computed the average of those 5 times. Had she chosen 5 different days, she would have recorded 5 different times and thus would have computed a different value of the sample average. Because big Y bar is random, it has a probability distribution. The distribution of big Y bar is called the sampling distribution of big Y bar because it is the probability distribution associated with possible values of big Y bar that could be computed for different possible samples big Y sub 1 through big Y sub n. The sampling distribution of averages and weighted averages plays a central role in statistics and econometrics. We start our discussion of the sampling distribution of a big Y bar by computing its mean and variance under general conditions on the population distribution of big Y.